So what I did this week, Al was playing with his steering on his real lawn tractor as opposed to the simulated lawn tractor that we've been playing with, and it doesn't seem to work correctly. So I was going in looking at it, trying to figure out why, if I had any ideas why it wouldn't work. And let me see, pictures, and let me say share screen. Here, let me say again, share screen. So screen 2, make that bigger. Okay, so if you can see that, this is what it looks like if you run it on the simulator. And this is so over here on the left, so you can see my cursor right there at 0, 0. This is where he's starting off with his lawn tractor. The lawn tractor is pointed down, and then over here is the path. Let's see, I don't think I have a better path. So anyway, the path goes from this dot right there is where the path starts, and it loops up around. It's easier to see down here, assuming we could see that point right there. The path goes from here up around here and back down around here and around here, and it stops at this point right there. So when it gets to that final point there, Pure Pursuit says, "Oh, I'm done," and shuts off the forward velocity, and should sit there and sit there and wait for you to do something. So anyway, he's trying to go from when done on the simulator, you just start this up. You say start gazebo, start the Ackerman controller that goes along with the gazebo. You start a couple of other things. You start up the Pure Pursuit module because that's what we're using to navigate with. And then once you get everything running, then you say publish a path. So the thing is sitting there ready to go. You say publish a path, and when you do, then this dot shows up saying that it now recognizes this path is there. And then let's see where the other things here. So this one right here, I'm showing this is the requested velocity. It's in the command velocity speed, and then it's got the ODOM is the actual speed coming from the vehicle. So that's the requested speed and the recovered speed. And being a simulator, they're nice and they match each other exactly because it's all simulated. And the one down here. So at this point, when you say publish the path, Pure Pursuit starts, it puts out a velocity and continues the velocity until it gets to the end and then drops back to 0 over here. And then down here, as soon as you publish the path, it starts controlling and says, "Oh, gee, I'm pointed in the wrong direction." So see over here on the left, we start off here with the vehicle pointed down, and it's got to get to this point over here, the first point on our path. So what it does, it says, "Oh, in order to get there, I need to turn, so I'm pointing at that point." So it has to turn this way or turn this way, and it seems to like to go down. So basically, it says down here, it says turn the steering to a hard left. So it turns it over to the hard stop, starts driving forward, and you come around here until you're pointed at this target point over here. And this top plot over here, this is what they call the off path error. So when we start off, it says we're like 21 meters off the path. And the way they define that is if your vehicle is pointed down like this, it's saying how far in a perpendicular distance from that path is our target that we're looking for. So if we're pointed down, then it's about 21 meters over to where this point starts. So it starts up here at around 21 meters. Now, as we start driving forward, it's the vehicle swinging around, and we're getting closer and closer to pointing at that point. So as we come around here, we get it right about to there. Our off-path error drops down to 0 or close to 0, which means we're pointed right at this point over here, and that's what it's showing on this plot here. So it comes down to the point. So right here it says we're pointed at the target, and we still have velocity, so we're still moving. So now it just continues to drive along here in a straight line. And if we got off for some reason, I think it keeps recalculating, so it keeps trying to pull it back on the point to get to that point. So when you get about here, we're now close enough that there's a concept of the look ahead distance. So when we get within 2 meters of the point we're trying to get here, it then goes back and goes to your path and says, what's the next point on the path? It's 2 meters out. So this is 1 meter, 2 meters. So it pulls up this point right there. So it's coming along from right here. From there, it switches to this point, and then as you drive along, you can see the 2 points. The 2 points will click along the path and do what they're supposed to do there. So again, then down here, as we're driving, once we come around here and we're now pointed at the point, you notice the steering drops to 0. So the steering says drive straight ahead. The speed says a constant 0.5 meter per second the whole time we're running here. And as we're going around here, you can see when we start off pointed down, it says the IMU on the simulated IMU says that's minus 90 degrees. And then as we rotate around here to point this direction, it comes up to a little more than, I don't know, it's about 10 degrees or something. If I had PlotJuggler running here, we could actually go ask it what these numbers are. But anyway, it thinks this slope here is around a 10-degree slope, and that's what the IMU is telling us. And then as we approach the point down here, let's see, it's actually switching internally. So it switches from this point to this point, and we don't see that. That's the only indication we get is looking at this chart here. And then as we do that, it'll say our off path error is it's what, like a meter. So once it starts turning, it's going to say we're like 1 meter off of wherever this point is. Once, from the direction we're traveling, and then the perpendicular to that, it says how far is that perpendicular off from the point that we're looking at, so that you see a little bit of stuff going on. I might have a zoomed in view of this that's easier to see that. And then down here it says, oh gee, our path is off, so it affects the steering. So the steering turns a fairly hard left, and I think it's like 0.7 meters or 0.7 radians, where his full left is 0.96 radians. So it turns like 3/4 of the way, and then basically that generates this curve based on this steering angle down here. So it simply goes around there until it lines up, and then up here you'll see that it drops back. Again, if I had zoomed in, I guess we can see a little bit there. So as we're turning, it goes like that. And then as we get back on the straight line going up, it goes back to a steering, or an error of 0, which translates into a steering of 0. So this is going around that first curve. And then here's the steering of 0. So it keeps driving straight until it gets to the top. And then this right here, if we look over here, get these at the same time. So we're driving on the left, we're driving up like this until we get to this point. And you can see on here, when it gets to that point, this will say turn to the right. And then so it says turn to the right and goes this far. And then once it gets that far, then it says turn to the left to make this curve around here. And that's what this big one here is. And then it comes back down here and it says turn to the right again. So we get right here, and then it does this curve. And then at this point, then we're back to a straight line again. So by looking at this plot, you can see this right here is the light bulb shape. And then again, here's a straight line as we're driving back down. So that's what the whole thing's doing. And as it drives around, we can watch this plot here. I have this plotted out in degrees because I don't think in radians. So anyway, this is, as the thing drives around, we can see it started at minus 90. And as we're driving towards the point, it's like, let's see, I'm going to call that about 10 degrees right there. Well, maybe it's, oh, right there, it's 13.102 degrees. See, that this red line is what PlotJuggler is telling us. That's the point in time that we're looking at. So that orange dot right there says that is 13.1 degrees. I got distracted for a second there. I saw things flashing on the screen. So anyway, as this drives along, you can watch the IMU coming out that tells us what direction we're pointing. And theoretically, if you look at this does all make sense based on the fact that running on the simulator does seem to give us a reasonable. In fact, here's the results down here. It starts here, and it's completely in control the whole time. It drives over here, drives up around here, drives around the path. And when it's all done, it comes here and it gets there and it actually stops right there. And that's why the plot just, the plot stops right there. If we look over here, we can see over here in the upper right-hand corner, you can see this is the off path error, and it just stops at that point, and that's because it reached the target point and shuts down. And right below that, you can see the velocity goes from 0.5 meter per second down to 0, and so the vehicle will actually come to a stop. And the IMU keeps going because that has nothing to do with pure pursuit. And then down here again, the steering, it was already close to 0, and once it pure pursuit shuts down, it forces a 0, so it'll just sit there. It should sit there in a stable condition now, not do anything until when you publish the next path, and it will take off and drive to the path and follow the path. And up here, you'll notice that this is not following exactly, but if you create your path with a tighter tolerance, put your points on the path closer together. Instead of Al's got his set to 1 meter apart right now, so there's a point here, a point there, a point there, a point there, a point there. But if you cut that down to say a tenth of that, what is that? 100 centimeters? No, it's 10 centimeters. 10 down to 10 centimeters. So you got a lot more points. When it comes around the curve here, it's going to follow that much closer. If you care about that, if you want to follow closer, you can do that. If you just want to turn around, you may not care. And the other thing is, it's got the concept of look ahead distance. So if we start right here, if the vehicle, well, the vehicle turns and sitting right here. So when it's sitting right there, it's looking two meters out in front of us and picks at this point. So if you look at my thumb right there, the thumb is my pointer right now. So we come around here, and when the vehicle's sitting right here, it looks out 2 meters. So it's going to try to control to a point right there. As we drive forward, then we get right there, then it's going to switch again. It's going to pick the next point. So it's always looking, the way his is set up, it's always looking 2 meters out in front of us. And if you put smaller increments there, you just get better control. And then what was the other concept? Something about the speed. No, I was thinking the look ahead. So anyway, this is a system that's working correctly right now. So we basically put the thing here, we publish a path, it drives all the way around and comes to a stop. So the next thing is, this is what Al's vehicle is currently doing. And it's kind of messy, but you can see here, it's the same concept. We're starting right here at 0, 0, and it's pointing down. Now what he did was he started up, he started everything up. He started up the pure pursuit, and then he immediately published a path. So right here, this, you can see over here, when you publish the path, this point will show up. And before you publish it, that point is not there. So you can, if you're watching this in PlotJuggler, you'll see that happen. That happens fairly soon. That will pop up, and when it does, the speed that pure pursuit is requesting will jump up to the 0.5 meter per second, and it will stay there until you reach the end of the path. Which again is if you come all the way back around and get to this point right there, that's the end of the path. That's where the speed drops off, and the steering, well, here, let me zoom in on that. So the green here is the requested steering from pure pursuit. So again, over here, when we start, as soon as it sees a path, pure pursuit starts controlling and is trying to drive to that point, even though Al is ignoring it at this point. He's got a switch on his. It's either auto mode or manual mode. So with it's set to manual mode, it's taking the speed and the steering from his joystick. So even though pure pursuit's screaming out here, saying, "Oh, I want you to go this fast. I want you to turn hard left," he's just totally ignoring that right now. So that's one more thing to keep in mind if you're watching the plots. That's what's happening. So basically, he immediately starts it up, and pure pursuit's trying to control, and it's saying, "Yep, that your point is 21 meters off to the left." And until we start moving, that's going to stay, everything is stable right there. So then down here, and I don't have a plot of how fast he's actually going. This is just a request from pure pursuit, how fast it wants it to go. But I think maybe in the next plot I might have that shown. It's a zoomed in one. But anyway, so back to his timeline down here. So down here, at some point later, I don't know, is it, Al, is this in seconds or is this in just random numbers down here?
Those are in seconds. At about 220, I switch it out of manual mode to auto mode.
Yeah, I noticed it's around 218 instead of 220 when this happens, but that's a minor point right now. So anyway, so like 90 seconds later, from when here's when he started it up, and then it published the path, and it's just basically sitting there stable. And then after this amount of time, he grabs his joystick and says, start, it says, turn the steering to whatever this is, like 0.25 radians. So he's saying, and this is a ratio, this green line here this is one hard stop, and down here is his other hard stop, so you can get an idea of how sharp he's turning there. So he takes his joystick and says, turn it, and if we could see the velocity, then right in here is where the velocity would come up, and he starts driving. And again, I don't have that plot handy. So let's see, what was my point here? Oh, so when he starts off here on the left, he starts at 0, 0. He grabs the joystick and starts driving. Let's take the bottom one's less cluttered. Here, I can get both of them in. So he says, turn the joystick to the left this amount and start driving forward at some speed. So if you watch it, it comes down to right about here or so. And then back on the right, he moves the joystick a little harder. So he gets a tighter curve right here. And then he moves it back to the shallower angle again. And it continues long to right there. And then if you watch his velocity, he comes to a stop right there. And then if you're watching on the plot, then his point, because this red point is what we'd see moving around. So the red point would be sitting right here. Again, my thumb is saying it's right there. And then he's got something about his RTK fix popping in and out. So it goes from there. And then all of a sudden from there, it jumps over here to this end of this line and sits there for a couple of seconds. And then it starts slowly coming back like this. It gets right about here and bam, it jumps back to this point. And so the red dot would be sitting there and everybody's happy at that point. So if we come over here, that's what happened, right? This glitch right there. That's what the, well, that glitch right there is what happened when the thing is fully locked on. And again, it's requesting the speed of 0.5 meter per second, but he's ignoring that. But you can see up here at 0, this is actually around, I think it's actually around 10 degrees, which means he came around here and he started turning towards the point. And this right here is where the GPS was jumping around. And once it was stable right here, it says it's pointing, it's almost pointing directly at the target because this is in meters, I think. So it's like, it says the target point is like 1 meter off of the path that I planned. The path that I'm pointing at right now, it's off 1 meter to the left of that, which considering that 10 meters away, that's pretty good. Pretty good. The fact that he's almost pointed at it directly. So then he sat there for a while, not moving. And then he came back down here. Something about this point right here, I kept thinking, what is causing that? Why is it drifting off to the left? And I looked at it for a long time and finally, because the plots I here don't really show that. The heading's coming down a little bit. So that says the vehicle is moving and it's rotating to the right a little bit. And then down here, so the result of the calculation. So this right here is your off path error, saying the point that's 10 meters away is moving further and further to the left as I'm doing this. And I think we might be moving forward I know we're moving forward because we can see the heading here is drifting off to the right, which means we are moving forward in a fairly wide curve is what that's telling us. You can learn a lot by analyzing these plots to see what's going on. So down here, he's ignoring the steering angle coming out of his pure pursuit because he still got it in the manual mode. But this steering angle you see starts drifting up here and it saturates right there at a full request for full left hard stop. So it comes up and saturates there. And see, can we see that on the plot up here? So it says the point that we're looking at is moving further and further left from the path we're trying to drive on. So it's taking this value here and calculating a steer angle down here. So it results in this until it gets to the point, says we're at a full hard left. Now what he does, now he flips the switch and says, put it into auto mode. And you can't really see what's going on here. So I'll move on to the next plot here. So here's a slightly zoomed in version of that. And here's what we were just looking at. As I said, here's where it's slowly drifting off to the point is drifting off to the left of the line. And then down here, that generates a steer angle that goes over until it saturates at the left hard stop. And then right here, he flips the switch and it starts it starts controlling. So since the peer pursuit is requesting full hard stop, the blue line, which was his joystick, is now locked onto his green line. So it jumps up. So it says turn the steering full left. And when it does, the red line is the that's his actual steering. So this is what the wheels are coming over and trying to go to a full left hard stop. Now, looks like a couple seconds into it, the peer pursuit says, "Oh, wait a minute! I don't want to be at full left hard stop," and it starts moving to the right, and it says, "Go to full right hard stop." And so then the blue line is tracking that, so it says, "No, we should bang over to the other side." So you can watch. This is the actual wheel position here. The red is fairly violently, going from full left to full right to full left to full right, and that was the big question. Why is it doing that? And then this out here where it seems to calm down, if we go look at the see, he started off right here. Again, look at my thumb over here on my hand. He started off right here. This is pointing right at the point. And you drive forward, then it starts waving back and forth harder and harder until he gets right about here, and it starts going vertical. Now on this vertical line, it was controlling pretty well going up there. And you can see here that these things are not all that wild anymore. They're not they're moving back and forth a little bit, but somewhere in here is the straight line that we're driving on. And then again, this is probably at the curve at one end. So part of this is probably the fact that it started off at a full hard left, and that caused it to oscillate. But then that doesn't explain why it did it later. Over here, it's doing something really stupid. One of the things I noticed was, while this is under control here, see the green line is saying that's the command coming in from his modified command velocity. See up the top here, the green line says command velocity angular Z, but he substituted a steering angle into that, and it's requesting, the green line here is what it's requesting, but for some reason his actual requested steering on the vehicle isn't following that. I don't know why. I would think that'd just be a simple scale factor from his requested angle coming in here to the angle he's going to send to his steering. But for some reason, there's something funny going on between those. So that's something else you might want to look at there to figure out why those two don't match. And it could be there's something in there that I just don't realize you're doing. But that's something that looks a little bit funny right there. Now, the other thing, and we were talking about just before the meeting started, if I go back to this plot, see right here, here's my 0 point where you're starting out. So apparently, looking at the thing, your vehicle was pointed down at this point. So it's pointed down in this direction. And if we go look at it, it says the IMU is at minus 90 degrees. And if we assume that if we're using the ENU format, then it says pointed to the right or pointed to east is 0 degrees. And if I go around this direction, it becomes more negative as I go in this direction. And that would say that would hold true here, because if this is 0, then that would be minus 90 going that direction. So here it says on the simulator, the value from the IMU says minus 90 degrees, and that seems appropriate. And then as it moves around, it basically follows what we're doing. But if we go to the this one, so again, coming back over here, you're starting off at this point here, and since the vehicle going like this, I assumed the vehicle was pointed down, just like in the simulation. And so at that point, I would expect the IMU to be the same value. But if we come over and look at the IMU, it says it's at 0 degrees. So instead of being minus 90 degrees here, it says it's at 0 degrees. So that's a rotation being off by 90 degrees. Now let's look, see if it's going the same direction. See if we go this way and we turn left, if it comes up like this. So let's go check that and see if that's doing the same, if that plot looks the same shape. And yes, it does. It does. So we go here, we turn left, it comes up. So the direction is correct, but it looks like it's got a 90-degree offset between one or the other. And I'm not sure which it's supposed to be, because in the simulation here, I'm not sure that IMU is actually being used for anything in the simulation, but on his actual vehicle, I know for a fact he's taken his IMU value here, and that's what is being used for most anytime he needs an angle inside of his stuff. That is the the value it's using. So that might be an issue right there. Just check the IMU to see if it's putting out the right angle or not. And then, as I say down here, when I was questioning why your command velocity here, the command velocity here is the green down here, but your actual requested for your steering is bouncing back and forth, and I don't know where that's coming from. So you might want to look into that too. That's the two things that I know right offhand. One other point I'll make is, since you did immediately publish a path before you started driving around, so you published a path, and Pure Pursuit is trying desperately to control it. It's saying drive this fast and drive at this angle, but you're in manual mode. You're driving around and you're looping around like this, and the thing starts bouncing back and forth. What you could do is you could drive it, say, from the point you start at in your driveway, just drive out to some random point, say around in here in your yard, and just let it sit there until your RTK locks on and everybody's happy. And then at that point, then publish your path. And once you do, then this path point will show up here. And then, say, like out here, if you wait till here to publish the path, then we know everything is stable. It's just sitting there. So as soon as you publish the path, then the speed will come up. Say, okay, I want you to start driving forward at this speed, and then your steering request will then, it'll already probably be at 0 at that point. So it may not have as wild of variation there, but it does look like, even though you created the path here and you blatantly said, no, do what I tell you, and did a lot of driving around, it looks like it's trying to recover. So I think it may not be an issue. I don't know. As long as you totally ignore it until you're ready to go, that may work out just fine. So that's kind of where I was at on that. I decided sometime yesterday that let's see, I probably don't have that zoomed in view here. Yeah, here's the zoomed in view, because I was looking at the off path error banging back and forth, and I thought, well, it's taking that and generating the steering angle, the green steering angle down here. And I thought, well, then obviously this off path error is being computed incorrectly, causing the steering to do that. And then I realized, well, since the vehicle is actually, if this is his IMU right here, the thing is actually, the vehicle is physically moving back and forth. So the off path error is being calculated from that, which calculates the steering, and the steering then affects your heading again. So it's a chicken and egg thing here. I don't know if this is causing the oscillation, or just the fact that the vehicle is physically moving back and forth, which is, so this thing's going to detect that and then cause the steering to do that. So at this point, I'm not sure what to make of that, but there's more stuff I can dig into. Oh, here we're talking about the velocities here. This I think this is the one that's the values going to his RC servo to control his transmission. So right here, this is probably when he's driving around. So I don't have the velocity request. So right here, this is probably when he's driving it manually. And then when he starts up Pure Pursuit, then it jumps up to this point and stays there. So I assume that's what that's doing is, that's an indication. I like to plot the one that's I guess they're all shown over here. I like to pick the odometry feedback. That shows me how fast, that's my recovered value, how fast I'm actually going. So as you move regardless where the command's coming from, whether it's coming from the joystick or coming from Pure Pursuit, it'll have a line out here telling you how fast you're actually moving. So when I go back and look at the plot, like say down here, when he's driving around, you would see, like right here, you'd see a thing saying you're going this fast. And if you stop, then it drops down, or no matter what you're doing, you can see the actual speed while it's moving. And as I said right here, it's probably moving there. Well, according to his transmission, his transmission says, yes, we are moving. And that's why we're getting a change. Any of these plots we look at right there, he is moving and his heading's changing while we're moving. And you can see on here that, yes, we are moving in a forward direction. So that's, again, if you analyze these plots hard enough, you can see all kinds of interesting things going on here. And this is something Al took this out in his yard and drove it around and created this bag file. And I'm just pulling up his bag file and going through his plots just see what it looks like, see what he's doing. Since we're on here, let me just ask, what's your topic that says whether you're in manual or automatic mode?
There's a mode switch. I think it's data element 7 on that my array topic. Let me just confirm that. Oh, how do I get out of full screen? "30 seconds away."
Is it steer angle actual maybe?
No, that's the actual, that is the, in radians, the current steer angle of the tractor.
Yeah, okay. And now,
Um,
so for some reason on my Miro, it put a box over the top of everything, so I can't see what's going on. Oh, no, it went away.
The radio control mode is data element 10 in the my array
Okay.
details.
And that I could derive that because as I watched the plots on here where I'm plotting the stuff out, I can see right here where it switched because your velocity switches from whatever you had up to here. So that's where you put it in auto mode. This is also where you said at 220 it happens. So I can also see here when the steering or the when the steering goes from this point and jumps up to here, that tells me you put it in auto mode there. So I could derive what was happening, but I didn't know what that was called. And there was one other thing I was wondering about, and maybe I guess up here this is this indeed your my array topic data 1? Is this indeed your transmission? That's what you're telling the transmission to do. That's your position on that. It says servo target position. Is that what that's telling me there?
Yes, that is, that's literally the raw number that's being sent to the Super Servo 200.
So another point on that, you're saying your transmission dropped out several times. Well, if you watch that number come across here you got a burst of times where it was clicking on and off, and here you have a burst of times it's clicking on and off. So you're saying, is it because you got too much current on the servo or because something's telling it to shut off? Well, you can see on this plot right there that it's doing, for some reason it's doing that. And I didn't know what fed into that, so I didn't know if there's anything else I could look at to track backwards on that to see what it was doing.
Yeah, it's
I do know the whole
definitely,
time pure pursuit is saying go at half a meter per second. So it's not the command velocity value coming in that's doing that. There's something in between there that's causing that to happen.
yeah, that's one of my safety switches is getting triggered, and I'm trying to fix why it's getting triggered. It's, so I can talk about that a little bit when I have the floor.
Okay. So anyway, that's how far I got with this. And I'm still a little bit baffled. And one of the things I thought of is that I could go back to the actual pure pursuit code and go through there. And first of all, look to see what is it subscribing to, and then how are those values being used. And I noticed in there it subscribes to the odometry topic, subscribes to the path published topic, and then somewhere it's using a transform listener to do something. And there was a comment somewhere in there. It said, we're using the odometry information, but we're getting it from the transform instead. So again, it's one of those cases where, there's data there, but you don't know if it's being used until you analyze it fairly hard. So that's something else to consider on that. So anyway, I was gonna look at that a little harder and see if I can figure out how that's working, and what values is it actually using. So that's all I got to say for the moment.
Well, thanks for taking time to look at that bag file and doing those plots. You're really proficient at using PlotJuggler.
Oh,
I,
before we move on, the comment you put in, let me see what the comments are. It said, you're saying, here's your Miro. Next one's pointing to your, what's that code? Yeah, that's pointing to code that I'd have to look, I had that pulled up. I was gonna look at both of the Pure Pursuit and your GPS to ODOM converter and see what you're doing there. It could be that um it could be that in there you're already translating that heading. So you might subscribe to IMU, and then inside of that converter, you might be rotating it there. So it could be you're actually taking care of that. It's just the when I was looking at it, when I was plotting it out, that's what I could see. I was just going directly to the IMU. So it could be that's really not a problem. It's just that maybe you've already fixed that.
Yeah, well, while we're on the IMU, let me just point out that this chip robotics IMU and it's a relative, the heading that it provides is a relative heading. So no matter where you start, it's going to give you a 0 heading. And I'm trying to remember, is if in the driver of the IMU or the launch file of the IMU, whether it lets you put in what your actual heading is. Yeah, see, here's this initial yaw.
Well, if it always starts at 0, that explains why I'm seeing it as 0 on the plots, because I was going directly to the IMU. There's probably other intermediate things I could look at, but I didn't, without knowing
Yeah.
your whole processing path, I didn't know what else to look at.
But I thought I had, it's again, it's a wonderful thing to go help debug, because I can tell you that I know the initial heading is obviously not exactly 0, and I have put in minus 90 there. And
So it could be if I go plot out the ODOM message, either the ODOM topic or look at the ODOM transform, then it should have your corrected value there. So I should be able to see it. So I just didn't realize this is what you were doing.
yeah, and as I'm talking, I'm reminding myself of how this works. So it's not like you know, there's so many things to keep track of every time. I'm like, how did I do that again? So, I mean, the compass heading for the tractor coming out of the garage with or without RTK GPS is, almost due south. There are 184 degrees. I did some math that I'm questioning now because due south in ROS radian terms, isn't it minus 1.57, half of pi, negative half of pi? So I may have that value incorrect.
No, it'd be minus pi, I believe. Well, again, when you say in ROS terms, we got the whole NED versus ENU. But
Yeah, I'm not remembering my calculation for getting the minus 90 out of that because I can confirm factually that it's 184 degrees as a compass heading.
so as a compass heading, it would be 180, and in ROS terms, it should be minus 90 because it's minus 90 from east. So yeah, I think that minus 90 should be what you want, because the simulator says minus 90 when it starts up.
So anyway, back to, and again, I'm really liking this Miro whiteboard, and I don't know why that's there. I've just put some of the testing, some of the same plots that Jeff has put out in PlotJuggler. So there's actual and planned. this is again, one of the things that Jeff taught me how to do is use this, publish an array that has internal data elements in it that I wouldn't otherwise, have a whole ROS topic to publish. So I've got this my array with up to, well, maybe a dozen or so variables at the moment. These are two of them, which is useful to help to debug. But my problem statements at the moment, I had a problem with my map being off to reset my microcontrollers that provide left and right ODOM statements. That fixed that. We talked about the wavy steering. That's still, I have here, is the correct TF being used? So anyway, as Jeff said, in the input into Pure Pursuit, there's ODOM and TF, and both of those are areas to explore. The throttle stopping multiple times. Had two issues with that. One is the radio control unit, I think was a physical electric issue. And I also changed the timeout at a second, and I've increased it to 1500 milliseconds or 1.5 seconds. So hopefully that dropout that was caused by the LoRa, these are a couple of prints that show that. If Miro would zoom in here. Come on. Scrolling. It's not scrolling in. I've lost. There it comes back. Whoa, now it really came back. And I seem to move some stuff around I didn't want to move around. Well, I'm not going to bother cleaning this up for the moment, because I seem to have messed up my whiteboard, but bear with me a second. I'm going to stop sharing and see if I can correct this real quick. Well, I'll go ahead and share again. I don't. It's just, it got a lag. Waiting on the lag.
I will exit out and see if that makes a difference.
The other things I mentioned in the chat were I just put the link to the Miro board, and then I also put the link to the GPS to ODOM program that is creating the ODOM statement. Yeah, it's definitely worth investigating the IMU heading, and if that's all correctly getting into the I mean, this is the ODOM which tries to fuse together wheel odometry as well as RTK GPS for position data once RTK happens. And I have in here the initial heading in radians for the IMU. So that's always used as an offset when I create the ODOM statement. Bottom line is wavy steering, best place to explore after I get my safety triggers sorted out so it gets consistent data is looking at the IMU plus, as Jeff suggested, drive it in manual mode and figure out a way to start the launch statement from the laptop. I've got it locked down and the lid closed out in the yard. So see how to get that launch statement for the path. Do that from the yard and see if that makes any difference also. So that's where I'm at. And until today, I was happy with Miro, but I guess this computer I'm running it on is I don't know if it's my computer or what, but being a little cantankerous today. So these are some of the plots that you can see. This is, well, what I used in order to find out that I think my radio control was dropping out. So it was dropping out and there was like a 10-second lag, and that told me that the microcontroller on the radio control was resetting itself. So I think I've got that fixed. This was one, a display of the command. It says command velocity, or I say command velocity, but actually the microcontroller on the tractor is getting data through a serial statement, not the actual command velocity topic. It's published by a Python program put out on a TTL board. And so those red lines show that that was timing out. I haven't quite figured out. This is my, so this TTL board is physically connected via USB to the laptop, and that there are TX and RX wires coming out of that over to the microcontroller. This timeout, or this is taking somewhere between 0.2 and 1.2 seconds. I had the safety switch set at 0.1 second. So I'm back to tracking that. You know, I started tracking the actual length of that, or the time, you know, the actual time it was taking for each one of those messages, and that so it varied. So but it never got off over 1.1 seconds. So I'm going to increase that to 1.5 and see if that cleans up my safety issues. So bottom line is more debugging to do and a few things to look at. I'm probably going to put a lot of the emphasis on the IMU and making sure the ODOM statement is right and the heading is right, because that would definitely cause wild steering if heading is being used in this vector math that the pure pursuit does, which, you know, I have to admit, all that vector math is, I can do trig, but high-end calculus is not my thing, so but we'll get through it. Anyway, that's it for me.
You also ask on the chat, how do I get degrees instead of radians? Well, do you have PlotJuggler handy that would pull up and run on this computer?
Sure, hold on.
I could try logging on with my other computer here, but that would probably be a total fiasco. So if you go over to say on the left under IMU, open up IMU, pull that down, and go down under orientation. Keep going. So look under orientation. And for some reason, this one already has it has the quaternion. You can see WXYZ, which is a quaternion, and that I think quaternions are unitless, maybe. Anyway, whatever they are, that so so that particular angle shows up as a quaternion. Plus, it's got the yaw degree, pitch degree, and roll degree already done for you at that point. So if I plot those, you either get degrees or you get nothing. Now, what you can do is you can put it in degrees and you go into PlotJuggler. If you right click on that plot and then say apply filter to data up at the top. And then at that point, you can say, go to click scale and offset down at the bottom. Let's see, what is it where, let's see, the picture's in the way, I can't. Anyway, I assume that's the one in degrees. So on the right there, you can say value multiplier says 1.0 on the right. And then right below says useful constants. So if you want to convert that to radians, click on the one that says degrees to radians. And then I think you have to say apply. No, I think you just say save. And then when you're done, it'll be in, that should be, your label still says degrees, but it should be in radians now. So anyway, that's one way you can convert it back and forth. If you have a plot that's already in degrees or in radians, you can apply a scale factor to do that. Now, the other way to do it, go back over to your menu on the left and close down the IMU one. Let's see if we can find one that's does not have the how about what's under heading from IMU? Or is that just a single? It's just a single value. It looks like it's in radians.
Well, it's
So go back.
yeah, it is I mean, that's saying I'm starting off at minus 1.57, and what's interesting is it doesn't never get up to 360 or never gets to pi.
Well, anyway, that's beyond what we're talking about at the moment. Go back to the left and pull down your ODOM menu and look under pose, and then look under, I think I'll say pose again, and then look under orientation. I'm looking for a quaternion. Well, we'll go ahead and use this. For some reason, that one's already converted too. So if you want to convert this yourself, what you do is go up the top where it says tools, the top, clear to the top, yeah, up there, and say quaternion to RPY. Now what you do is you come over here to the left and you have to grab one of those values, and I always grab the W. Yeah, okay, that works too. So what it does, it says we're going to take this XYZW and we're going to convert that to RPY. So you notice there it says, then at the bottom says output, it says ODOM pose orientation, which means it's going to give it that name. Now on the menu at the top there, it says XYZW, and then it says output down right there. Where it says output, that's just give it a name, and basically it's copying whatever name came in. So just keep that in mind. You don't have to do anything with it right now. So now over on the left, you can say convert that to radians and convert it to degrees. It's got the little radio buttons there on the right. And so, yeah, right there. And then you can either unwrap the angles or not. So if you leave it wrapped angles, it's going to say go 0 to 360 and then come back. Or if you say unwrap, it's unbounded. So that's also a handy way to view things. So just say save. And now when you do, look over on the left at the bottom, there's a little box that says ODOM. If you open that box there, that's where it puts the new results. It took me forever last night to figure out that's where they're putting it. So now you have to open one more. So there, if you say click plot out yaw, I think you converted it to degrees. Yeah, it looks like it's in degrees. So there, that's how you can convert a quaternion to either. But first of all, you just have a quaternion and it doesn't have anything on it. You can convert it to either degrees or convert it to radians by doing this. And like on this one, so if on that same plot right there, if you go under just on the left, go up to where it says yaw degrees under the top box. Yeah, that one, and plot that one at the same time. That should be right on top of what you got. So basically you've just converted the same thing that was already there. Now, the only thing I can think of that why the orientation has pitch, roll, and yaw already in it is because it's a different, the message type is different than some of them will just come up and give you just an XYZ and will not give you the pitch, roll, and yaw. And for some reason, these it's already converted and I don't know why. So that's something I can look into one of these days.
Yeah, the bag file that I happen to have loaded here is I was I just left the tractor on trying to see if throttle changed, and it didn't, which is good. So I think I corrected my safety flag. So for an hour and a half or so, it gave out the same data and didn't drop. So that's good. But if I put in, oh, let's just take that back file.
And to find a source for a quaternion, if you look under TF, that might have quaternions that don't have the pitch, roll, and yaw already converted. Trying to think what other.
Oh, bummer, I lost that custom series. Back files.
Anyway, go over to the left on your menu there and pull down TF and see if we can find a quaternion that doesn't have.
You want ODOM or baselink?
Base ODOM. That base link look ahead, that if you go through and plot those out, that has some really stupid looking stuff in there that it's kind of oscillating, but it was doing that both on the simulator and the other one. So look under rotation. And there, so see there you have one that it's a quaternion that does not have pitch, roll, and yaw yet, but you run through those same steps. You do the tools, convert quaternion to RPY, and then just drag one of those values into the appropriate box over there. Now you can either convert that to degrees or convert it to radians.
What do I need to do?
What do you want it to be in?
Oh, let's try degrees.
Okay, then that should do it. And there's your there is your value notice. And or no. Now in the lower left hand corner, there in that box down there it says TF. So you have to go open it up to get the new one. So that's part of the one that was left over that you had there. So you can take the yaw value from there and plot it, and it should be right on top. So that's two things to keep in mind. That's how, if you come up with a quaternion and rather than trying to go somewhere else, convert it, this thing will do that for you. So that's a handy thing to be able to do. The other thing is if you right click on your plot, you can bring up there's all kinds of stuff you can do with this if you can figure it out. So at the top it says edit curves. You can either, sometimes if you have more than one curve on the page, see there where it's got the orange one. If you don't want the orange one, come down to the left in that box at the bottom, and it'll have a little trash can. So if you want to get rid of that, you click that and that'll delete it completely. And then it has, you can change the scale up, the maximum scale up and down, where it says in the lower right where it says vertical limits. And I can't get that to work most of the time. So I kind of gave up on that. And then you can say that lines or dots. Yeah, it's kind of like plotting something in Excel. You just got ways it showed. So yeah, go ahead and whoa.
You said lines and dots?
If you want, you can do that. Sometimes that's handy because like when you're say printing out your path, that way it shows the actual dots on your path as it drives around. And then also if you say right click and the other thing you can say is apply filters. So up at the top there. And then you got all kinds of stuff you can do here. And scale and offset is what I normally use. And that way you can move the thing up and down. You can change the scale factor of it. And that's what we just did before. We said, why did we just do that? Oh, there, because we were manually converting between radians and degrees, but you can multiply that by, any random value you want. The radians to degrees and degrees to radians, they're just saying, oh, by the way, here's the numbers, so you don't have to look them up. But you can put in a one where it says value multiplier, you can put a 1.3 or a 0.9 and just, change the graph to whatever size you want there. And time offset, I'm not sure. Time offset might slide the thing back and forth. So, and then up above, there's all kinds of things. I see it's got moving averages and integrals and derivatives and outlier removal. I don't know if you'd use that on, that's more of a statistical thing, I think. So that might be better like on a scatter plot or something. But anyway, that's how you get to these things where you can do all kinds of, once you get a plot up on the screen, you can modify it by doing things like that.
Didn't change this data.
There was a button that says delete all data or something. Otherwise, just go down these tabs and close all these different tabs and just open a new tab to start over.
I think PlotJuggler just died. I think Zoom must use a lot of memory and my machine just died. Yeah, because PlotJuggler is not up there. Core dump. Segmentation fault. Didn't like something.
But since I hadn't used PlotJuggler for like 2 years, I had to go through and remember how to do all this stuff. And I thought it wasn't working, but it turns out it really is working. I just have to figure out how to make this stuff work.
I was just particularly interested in the. Now I've got some sort of. It's really not behaving very well. Yeah, see, it didn't find that custom series. Excuse me.
And it could be that when you go to say save a layout, it's got various options there of what you can save. So over on the left there where it says layout and you just said load layout, you can say save a layout and see how, to go that one there. And save data source, save scripts. That could be they don't let you save custom series. I don't know. That hadn't occurred to me that would be an issue. So I haven't looked at it.
But again, it was tools, quaternion and then pick which one. Like the
Yeah.
T.
So sometimes you'll find a quaternion by itself. It'll just have the XYZW, and sometimes it'll have the XYZW, and then it'll also have the pitch, roll, and yaw for some reason already in there. And I'm not sure who's putting those in there or why they're in there, but you can do it either way you want. So that's just some handy things to know.
This bag file is still, that never changes. Yeah, definitely I got to figure out whether the TF and the ODOM statement are being published with the correct rotation. So that's a good place to start. Highly likely that's the problem. That's the problem. If I look at the, let me pull up the pure pursuit code and see if you can tell me which TF you think it's using here. Bear with me a second.
And I may not be able to without a lot of digging, but it may also be obvious.
So this compute velocities function I believe it looks at all the poses in the path and it finds one that's greater than the look ahead distance, which is 2 meters. So, and then it does this transform to base length. Yeah, it definitely, I'm going to say that that TF that's the one to look at. Yeah, all this is a little bit confusing to me, but I'm going to say that's the one that better make sure is right. Okay.
That's all I got.
That's all I got too.